So looking at chapter 16, which is probabilities, for 16.3, we are going to learn something called a relative frequency. Relative frequency means in relation to the experiment that we are doing or to the activity that we are doing. So for example, like when we learn probability, all the probability that we learn, they are all considered to be theoretical. Theoretical probability. It means that in theory, that is the chances of the event happening. But if you do it a few times, it doesn't really reflect the probability. But let's look at something else that we call experimental probability. Which in turn is related to your relative frequency. So it's relative to the experiment. It means that in relation to the experiment, what actually happens or what's the probability of something happen. So we use a very, very simple example, like flipping a coin. So when we flip a coin, the probability of getting a head is definitely 1/2. The probability of getting a tail is also 1/2. But when I do it, so this is what we call theoretical. Means in theory, half-half. But when we do it for real, we do it for real, it doesn't really reflect half. Means maybe I get hits 20 times out of 30 times. So if I'm using relative frequency, or something we call experimental probability, I can say that the probability of getting a hit here is 2/3 or 20/30 because I only get it 20 times out of 30 times. But if I say I use a coin, it's not very accurate to relate to relative frequency or to relate to experimental frequency. But what's better is that if I use something that is completely impossible to determine the theoretical probability immediately. So for example, let's say I take an eraser. I flip an eraser. So maybe the eraser looks like this. Mark eraser means that one side is marked, the other side is not. So let's say I mark this side here like that. And then I start to flip the mark eraser. Means I just keep throwing it for a few times. Out of 70 throws, maybe I do it 70 times. The mark side is seen to be maybe 43 times out of 70 times. So no mark will be 27 times. So what are the probability again? So probability for it to be marked is considered to be 43/70 times, and then probability for not marked side will be 27/70 times. So that is how we use relative frequency. Or even if I say, today we're going to go outside and observe the number of cars that pass by. So observing cars, I also can use relative frequency. So when I observing cars based on colors. I'm just gonna sit outside and count maybe 50 cars. I get 21 white cars, black cars, maybe 5, red cars, maybe 7, 26 for 33, blue car, maybe 7, 40, and then maybe others, maybe 10. So if I ask you based on my experiment or based on my observation, what do you think is the probability of getting or of seeing a white car at, I don't know, 11 a.m. of the day? If I sit outside right now, this is what I observe. Out of 50 cars, I observe this particular amount. So probability of seeing a white car would be 21 over 50. Probability of seeing a black car would be 5 over 50, which in turn become 1 over 10. Probability of a red car will be 7 over 50. Probability of a blue car would be 7 over 50. Probability of other cars would be 10 over 50, which is 1 over 5. So this is how we actually use our relative frequency when we experiment or when we observe certain scenarios that we cannot really say that that's for sure. I cannot say that, oh yeah, I will see a white color car for sure half the time, because there's no theoretical probability. It depends on the amount of white cars there are on the road and the amount of white cars that actually comes out in the morning. Okay, so that's how we use relative frequency or